Okay, Dahlia asked a question, so I figured I'd post the way to do this problem on here, and it's a number 58. I'll just I put up the beginnings to the question right here, and this was Dahlia had asked about this one. So the question is, we've got 100 milliliters of CeNO3 and 100 milliliters of 3 molar KiO3, and CeIO3 has a KSP of 3.2 times 10 to the negative 10th. So first things first, we have to see if this is going to form precipitate. It tells us that it forms a precipitate, so we technically don't really have to do the Q versus KSP, because if a precipitate forms, then you know Q must be greater than KSP. So we don't actually even have to find Q, which saves us a little bit of time. So now what we're going to do is we're going to do our limiting reactant step. So we're going to jump right to step 2 and go CeNO3 plus KiO3 gives us CeIO3 plus KNO3. And we balance the equation. And then obviously our precipitate is this guy. So what we're going to do is we're going to find moles of CeNO3. So we'd go 2 equals x over 0.1. And that gets us 0.2 moles of that guy. And then 3 equals x over 0.1, which gives us 0.3 moles of KiO3. So then you do the limiting reactant step. I'm not going to do that for you because I'm not even like insulting your intelligence here. We'll just say the limiting reactant is that one, because it's pretty easy to see doing a little bit of stoichiometry that that's your limiting reactant. This is your excess. So now our next step is finding out how much leftover excess do we have. So we would go 0.3 moles KiO3 and then times 3 moles KiO3 over to this one, 1 mole CeNO3, and that gets us 0.1 moles of CeNO3 used or reacted. So therefore, you originally had 0.2 moles, and you would subtract the used moles, you'd end up with 100 moles leftovers in solution. So now what we're going to do is we're going to do the backward step here. So now we're going to take that this amount, and we're going to do a KSP problem. So just remember that number, 0.1 leftovers of this one. So I'm going to go take our KSP step. So this is our KSP problem now. So we're going to go CeIO3 water solid gives us Ce plus 3AQ plus 3IO3 minus, and remember that number was 0.100 moles of CeNO3, but really it was just the Ce. And then we have to make this our volume is 100 plus 100, so that's 0.2 liters. 0. And now we're going to do our KSP problem. We're going to go minus x plus 3x. 3x, 0.1 divided by 0.2 is 0.5 plus x. And now we would go KSP equals Ce plus 3 times IO3 minus cubed. Plug these values in. 0.5 plus x times 3x cubed equals our KSP is 3.2 times 10 to the negative 10th. We F2 solve it. Okay. x times 3x cubed equals 3.2 times 10 to the negative 10th, comma x. Okay, that gets us x equals 0.000287. So my final calculations are going to be the CE plus 3 is going to be basically 0.5. I mean, you could add on the 0.00287, but it doesn't matter. And then the IO3 is just 3 times that number. I don't know if that works. Sorry. I'm just going to use 0.000287 times 3, and then that gives me 8.6 times 10 to the negative 4th. Okay. And there's your answer. Alrighty. I'll give you notes for tomorrow in a little bit. There you go.